This lesson is find a unit vector. So here I have the original vector. I am going to square each of this term, and then after that add them and then square root. Now that will be underneath always 1 over the thing that you're going to square, add, and square root. So one more time, you're going to square each of these terms, add them up, and then square root. And then after that, multiply to the original vector. And again, it is always 1 over the square root. Okay, so 30 squared, 40 squared. Now if you square them and add them together, that will come out to 2500. Square root of 2500, which gives me 50. Again, always 1 over. After that, multiply to the original vector, and that comes out to be, if you reduce it, it will come out to be -3, 5, and then 4, 5. Again, if you can reduce, reduce. If not, leave them alone. Unit vector is technically the short version of this. This is the original vector. This right here is being shrink down. Okay, so one more time, this is the original vector. This vector is just the shrink version of the original vector. Okay, again, this is the original vector. This vector is being shrink down. That's why it is called unit vector, because it got shrink down. That's it. Okay, next we find the distance between each of the vectors. So it's very easy. All you have to do is subtract from them, square them. After that, add for each one of the terms. And then after that, you will square root it. Okay, so 0 minus -4, which is here, square. -5, subtract, -1, square. And then 2, subtract 8, square. One more time, 0, subtract, -4, squared, -5, subtract, -1, squared, and then 2, subtract 8, squared, and then just basic algebra. Simplify it, comes out to be 16, 36, add them together, gives me 68. Square root them, comes out to be 2 square root 17. If you want in decimal, it comes out to be 8.2462. So the distance between this vector and this vector is 8.2462 unit, whatever the unit is. Okay, it could be centimeter, millimeter, inches if it wants to be, but for now just unit. Okay, so one more time, the distance between this vector and this vector is 8.2462 unit. Okay, next we want to know that are the vector orthogonal or not. The word orthogonal just means perpendicular. One more time, orthogonal means perpendicular. So we want to know this vector and this vector, is it perpendicular? Or in another way, we say orthogonal. So we just multiply using the dot product. 8 times -2, which is here. -5 times negative, this is here. After that, just add them across, and it comes out to be -1. So it is not 0. So A, B are not orthogonal. So to be orthogonal, it has to equal 0. One more time. To be orthogonal, it has to be 0. One more time. To be orthogonal, it has to be 0. Again, orthogonal is just another way of saying perpendicular. All right. In the bottom example here I have a 1 vector, 2 vector. So 12 times 2, 3 times -3, -5 times 3, which is here. Multiply them, 24, -9, -15, add them across, and that gives me 24, subtract 24, that gives me 0. And since it's equals 0, UV are orthogonal. One more time, to be orthogonal, it has to equal 0. If it's not 0, then it is not orthogonal. Just like up here, since it is not 0, then it is not orthogonal. If it is 0, then it is orthogonal. So be very careful. One more time. If it's equal to 0, then it is orthogonal. If it doesn't equal 0, then it is not orthogonal. Okay?